Now let's examine how our CPU will execute this program by taking one instruction at a time. Before the execution begins, I assume that the program counter register of my CPU, the PC register, is preloaded with the value 000. I need this because whenever the CPU wants to bring in an instruction for execution, it looks at the program counter register to find from where the instruction should be fetched. So since my program is assumed to be loaded and starting from address 000, the first memory location in my memory map, I need to assume that my program counter has also been set to the same value. So during the first part of the instruction cycle, which is the instruction fetch cycle, the program counter will be used to find the address of the instruction that need to be read into the CPU. So in this case, the control unit will use the value of the program counter, which is 0 at right now, and send that value through the address bus and initiate a memory read cycle. So the value of the program counter will be sent through the address bus to the memory. And the memory knows that when it receives this value from the address bus, it knows that the CPU is going to read from this particular location. So to read this location, the CPU control unit will next activate the memory read line or memory read signal through the control bus. So when this read signal becomes active, the memory will copy the content of address 000 to the data bus. In this case, that address holds our first instruction, which is loading a value immediately after that to the register B. So the first part will be the get the instruction itself or its opcode itself to the CPU. So once the memory copy this value to the data bus, the control unit will read that value from the data bus and then transfer that value to the instruction register. Why? This is a opcode of an instruction. It's not the data that it is reading right now. So it has read the opcode of the instruction and that is stored in the instruction register next to the control unit. So once the instruction register is has the value of the instruction opcode, the control can see it and start decoding the instruction. So, but before that, as part of the fetch cycle itself, the control unit will also do one more action. That is to increment the program counter by 1 to point to the next location. The reason is that it has read the opcode at the initial address, which was 000, and now it knows that if there's another instruction, it has to come from the next location. So it anticipating that it updates the program counter by incrementing it 1, which is the length of that opcode. So after that, the execution cycle of the instruction cycle will start. So the first part the control unit will do is to decode the instruction. So since the instruction register is directly connected to the control unit, it can straight away start the decoding. And while decoding, it will know that to execute this particular instruction, which says that it has to read an immediate data value from the memory. Immediate value means that the data value which is immediately after the instruction opcode from the memory, and load that or transfer that value to the register B. So for that purpose, it will need to refer to the program counter again, because it will need to know what is the next immediate memory address after the first instruction which was brought in right just a while ago. So now we have already incremented the program counter by 1 to point to the next value. So straight away the controller can send the content of the program counter to the memory in the same way as earlier through the address bus, and then activate the memory read signal. So then the memory will copy the content of the new location, which is the location 0001, which is immediately after the previous instruction opcode into the data bus. So the CPU will then generate a signal for the bus interface unit to read this value from the data bus. Now this is a data value, and the instruction says that it has to be loaded into the register B. So while this value is being read from the system's data bus, the control unit will also send a signal to the register B to copy that value and store it in register B. So the register B will get this value from the internal data bus, which is the blue line, dark blue line that is shown here, and then copy that itself into the register B for storage until it is referred and used later by another instruction. And when you do that, now since the CPU has already fetched the opcode also from the memory, it will again update the program counter because it knows that last value pointed to a data value immediately after the instruction. Now when the next instruction cycle starts, it has to bring the instruction from the next location, so it will update again the program counter by another one, add another one to the program counter, so that now it points to the second instruction, which is available at the address 000010, or equivalently at decimal location, decimal address 2. So that completes the first instruction cycle, or the instruction cycle of the first instruction in our program. So at the end of the first instruction in our program, we have the program counter updated to hold the value 2, or in binary value 000010, which, and it points to the next instruction in the program. And we also have the register B loaded with the value content immediately after the previous opcode, which was the data value which is available in the address 0001. So the address 0001 is the immediate data after the last instruction that we loaded. So with this, the instruction cycle is completed and the CPU can start the next instruction cycle. As soon as the first instruction cycle is completed, the CPU will start the second instruction cycle. The process will be more or less the same. But by this time, we know that our program counter register has the value 000010, or else the decimal equivalent of 2 stored as the address of the next instruction to be fetched. So same as in the previous case, the control unit will start by first fetching the instruction itself, and for that purpose it will read the content of the program counter and send that content through the address bus, and then initiate a memory read cycle. So it will activate the memory read signal in the control bus, and the memory will respond by putting the contents of the memory location 00010, or decimal equivalent 2, into the data bus. So then the CPU will read the data bus, and since this is the fetch part of the instruction cycle, it will transfer the content to the instruction register overriding the previous instruction. So in this case, the content of the memory address was the code corresponding to load register C with an immediate value, like in the previous case. So as soon as this opcode is loaded to the register, instruction register, the control unit will start again decoding the instruction, and in that process it will see that it has to bring the immediate value after the instruction as the data value and store it in register C. Now in the same way as the previous, as soon as the fetch cycle is completed, the program counter will be incremented by one value, 1 byte, so that now it's pointing to the address 3, or 00011. So again, the control unit will initiate another read cycle to load the data item, which is immediately following the previous last instruction, or at value 00011, and then transfer that to the register C. And for that purpose, again, the control unit will send the address of the program counter through the address bus and initiate a memory read cycle. At the same time, it will also instruct register C to copy the value which is coming through the data bus into itself. So now the CPU, when the control unit activates the memory read cycle, the memory will put the content of the address 00011, or decimal equivalent 3, into the data bus, and the register C will copy that value from the data bus into itself. And again, the program counter will be incremented by another 1, so that it now points to the next instruction at address 000100, or decimal equivalent of value 4. So at the end of the second instruction, we have the program counter having the value 00000100, or decimal equivalent 4 point to the next instruction in the program, and register C having the value loaded with the previous instruction, and also register B having the previous value or the value loaded with the previous instruction stored in there. So that completes the second instruction cycle and the execution of the second instruction in our program.